Hello learners, welcome again on another video lecture on decoder and encoder. My name is Professor Subhash Arya. I'm working as a professor in Department of Electronics and Communication Engineering, Northeastern Hill University, Shillong. So let us begin with the definition. Decoder is a combinational logic circuit that converts binary information from n input lines to a maximum of 2 to power n unique output lines. So decoder is a combination logic circuit, means output in decoder depends on the present input condition. That is why it qualifies the definition of combination logic circuit, which is not the case of sequential logic circuit, where we have a feedback as well as memory elements. So that calls sequential logic circuit, whereas this decoder is a combination logic circuit in which output depends on the present input condition. In decoder, we have a n bit input lines, and output lines may be maximum of 2 to power n. Suppose n is equal to 2 input lines, so output should be 2 to power maximum number of this 2 will be 4. However, in reality, maybe based on the cases, this 4 number may be less. It depends on case to case. So having said, let us see this logic diagram of decoder is given in figure 1. So where we have this side, left hand side, we have input of n bit, and at the right hand side, we have a m number of output. M is equal to 2 to power n. And the figure 2 shows the diagram of 2 to 4 line decoder, means number of input bits are 2 and number of output bits are 4. So you see here the A and B both are 2 inputs. So A and B. Whereas Q0, Q1, Q2 and Q3. These are the 4 output lines. And the Boolean expression with respect to Q0 is A bar B bar, Q1 A bar B, Q2 A B bar, and Q3 AB. And the circuit diagram is mentioned here. So you see Q0 is A bar B bar, means from here and here. And while implementing, it means when we have input 0, 0, the Q0 should give logic 1. Whereas in AND gate, the logic is 1 when both inputs are 1, 1. For that case, we have little bit adjustment here in order to show that when A and B both are 0, 0, then Q0 should be 1. So it means this AND gate should give to logic 1. For that purpose, this extra inverter circuits are given. We will see. Let us see first this truth table which we were discussing here. So systematic truth table is given in figure 3. So A and B both are input and outputs are Q0, Q1, Q2, Q3. When inputs are 0, 0, so at that time Q0 will be 1 and rest will be 0. When input is 0, 1, then Q1 should be 1 and rest will be 0. When input is 1, 0, then Q2 will be 1 and rest are 0. If input is 1, 1, then Q3 will be 1 and rest are 0. So you see, this is the relationship between input and output in 2 to 4 line decoder circuit. We will learn further the realization of this 2 to 4 line decoder using simulation at virtual lab developed by IIT Roorkee. So let us see. This is the page, and this virtual lab is sponsored by Ministry of Education, and the particular experiment is on implementation and verification of decoder and encoder using logic gates. So let us see. First we will do decoder. So this is the aim. If we click on left hand side tab on theory, so you shall able to see the theory. So introduction is mentioned here. Binary code and digits can be used to store 2 to power n distinct elements. Then 2 to 4 decoder or demultiplexer. This is the block diagram. I have taken the block diagram from here, and figure 2 shows the circuit diagram. Then figure 3 is the truth table we have just seen, and this is the encoder which we will cover later. Let us see how to simulate. Before simulating, this platform wants to test your existing knowledge, that is called pretext. So here first question is this: BCD to 7 segment conversion is a decoding process, encoding process, comparing process, or none of the math mentioned. So you have already designed this BCD to 7 segment decoder, so it is a decoding process. Next question is that invalid BCD can be made to valid BCD by adding with. So A is 0, 1, 0, 1, that is a 5. B is 0, 1, 1, 0, means 6. C is 0, 1, 1, means 7. And D is 1, 0, 0, 1, means 9. So invalid BCD, as we know, in BCD start from 0 to 9. That is a binary coded decimal number. To express this BCD, we need 4-bit binary numbers, 4 bits. So we know 4 bits goes from 0 to 15, whereas BCD goes from 0 to 9. So what about rest? Rest 10, 11, 12, 13, 14, 15. It means how many? These are the 6. So these 6 invalid states can be made valid by adding 6. So that is why the answer of this question will be 6, which is mentioned here B. So 0, 1, 1, 0 is 6 in the decimal. Next question is device which converts an input device state into a binary representation of ones or zeros is termed as encoder. So this is the input device which code into binary numbers. So encoder, decoder, multiplexer, data selectors. Out of this, encoder is the correct answer. Next is a circuit that changes a code into a set of signal is called encoder. No, because we have already selected first one, then decoder, multiplexer, and data selector. So here the answer is decoder, a circuit that changes code into a set of signals. Next is which we will learn later on, but for the sake of answer, I will attempt it. Modulo 6 counter means a counter which counts 6 numbers can be built using a 3 elements of that shift register. So this is the quiz which we should attempt before going for simulation. So we have seen that all questions are correct. Its responses are correct. Now go for procedure of doing the experiment related with the 2 to 4 decoder. So you see this is the procedure is mentioned here. Step 1, connect 5-volt supply to the circuit. Then first press add button to add basic states of your output in the given table. Then press the switches to select a required input named A and B. Also check their corresponding output named as Q0, Q1, Q2 and Q3. Then press add button to add your input and output in given table. And 5, repeat steps 3 and 4 for next state of input and their corresponding outputs. And step 6, press the print button after completing your simulation to get your results. So let us implement this. Next one we will do this encoder. So press on the simulation button at left hand side. So you can see we have two options. One is decoder and another one is encoder. So let us attempt for decoder circuit, that is the 2x4 decoder. So this diagram shows the circuit diagram implementation of 2 to 4 decoder, in which first IC is 7400 hex inverter. Hex inverter means there are 6 number of NOT gate, and another IC is 7408, that is the 4 number of AND gates. So these connections have been made as per the circuit diagram shown earlier. Now let us try to do the way instruction is mentioned. If you need to see the instruction, you can click here. Again, all instructions are mentioned. Let us do. So we know when this first of all we have to give the supply to these two ICs. So plus VCC, that is the 5 volt, is given to pin number 1 of 7404, that is hex inverter, and pin number 14 of 7408, that is the AND gate. So now both ICs are getting the power supply. This is the first step. After that we have to verify the truth table, and we know the truth table 00 means state Q0, then 01, Q1, 10, Q2, and 11, Q3. These are the 4 outputs. So let us first give this 0, and both are 0, 0. Let us make it 0, 0. And then you see the Q0 showing the red light output, means this is the logic 1. So in order to write that truth table, we press just add. So you see serial number 1, inputs are 0, 0, and Q0 is logic 1 and rest are logic 0, which is shown in the our simulation. Now next take the input of 0 and 1, means A is 0, B is 1, and for that purpose you can see here Q1 becomes logic 1, and in order to write this into truth table, let us add it. Now you see second one, serial number second is 0, 1, and Q1 is logic 1, which is shown here glowing LED in red color, and here in the truth table also Q1 is 1, rest are 0. Then we check for 1, 0 means Q1 is 1 and B is 0, and you see here Q2 is 1, and that is shown by this LED glowing in red color. And let us also add this information into the truth table. So input is 1, 0 means A is 1, B is 0, and Q2 is 1, and then last 1, 1. So we make B is also 1, A is also 1, and you see Q3 is now 1. So we just add. So this is how we have verified the truth table of 2 to 4 line decoder. So in order to just recap, I will make it another like 0, 0, this Q0 add, then 0, 1, 1, then 1, 0, this will be 1, and this 0, Q2, and then 1, 1, you see Q3. So 2 times I have done. Means 0, 0, Q0 will be 1, 0, 1, Q1 will be 1, 1, 0, Q2 will be 1, and 1, 1, Q3 will be 1. And that is the truth table of your 2 to 4 line decoder. Now we can go for another step, that is the post test one, which is here for the sake of completion I will just include. So a decoder converts your n input to 2 to power n output lines. So D option is correct. A is not correct, which is n to power n, B is n, and the C is n to power 2, and D is 2 to power n. So as per definition of decoder, n input is converted into 2 to power n output line. BCD to 7 segment conversion in A is in a comparing process? No. None of the answer? No. Encoding process? No. It is a decoding process. BCD to 7 segment decoder, and name suggests also. Decoders and encoders are doing reverse operation. Yes, that is true. Means decoder converts an input line into 2 to power n, whereas encoder converts your 2 to power n maximum number of input lines to 2 and output lines. That is just reverse of decoder. Now, which of the following are building blocks of the encoder? Later we will see. It is implemented with the help of OR gate. And which of the following is a decoder IC? That is the number given here, 8870. So let us submit. So all answers found correct. So in this way, I will come back again on our this truth table of 2 to 4 line decoder. So we have verified the truth table mentioned here through virtual laboratory. Now, next, encoder. So just we have seen encoder is just performing the reverse job of decoders. So here it has a maximum of 2 to power n input lines and n number of output lines. Hence, it encodes the information from 2 to power n input to n bit code. So block diagram is here. Input lines are 2 to power n and output lines are n number. Just reverse of decoder. Block diagram is this, and symbol 4 cross 2 encoder lines. So here inputs are D3, D2, D1, D0, and outputs. So when one of the inputs should 1, like D0 is 1, it has been encoded as 0, 0 in the output. When D1 is 1, provided that other bits are 0, then it is encoded in form of 0, 1 as an output. When D2 is 1, then it has been encoded as 1, 0. When D3 is 1, then it has been encoded as 1, 1. If all are 0, then it is don't care condition. So that is not a valid case. So this is the relationship between input and output in case of 4 cross 2 encoder. So encoder converts your 2 to power n line information to n bit information. So let us do this simulation also the way we have done for decoder. So we can see here the circuit where we are using only OR gate, 4 logical OR gates. The IC number is 7432 and the truth table is given, just we have seen before, and the circuit diagram is given. Just this circuit is nothing but implementation of this truth table. So from here also we can see what are the expressions of Q0 and Q1 that has been implemented with the help of this IC logic gate, that is the OR gate. So you can see Q0 is here. So when logic is 1, Q0 is 1 when D1 is 1. So D1 plus here when D3 is 1, second. So D3. So Q0 is equal to D1 plus D3. Whereas Q1 is D2 plus D3 here. So you see here, that is why Q0, which is the LED, this one, is OR of, this is the output of OR gate of D1 and D3. So this is your D3, which is connected here, and this is your D1. So this is D1, this is D3, this is D2, and this is D0. So Q0 output, this one is implemented as here. And Q1, let us see now Q1, which is here. This is Q1. This LED is connected with the output of this or gate, and you see inputs are D2 and D3. So you see, let me remove this one. So you see here the one input is D3 and another input is D2. So D2 and D3 is the inputs for Q1. So we have seen this one. Now let us move to do simulation with the help of virtual gate. So again going to same platform, that is the virtual laboratory. So we have already done the pretext. Now going for procedure, and encoder is second experiment. Go for the simulation and select second, that is the encoder. So first task is give power supply to this IC of OR gate, that is 7432. So by clicking here, we are able to give plus 5 volt VCC to pin number 14 of this IC 7432. Now we we start, and you see we see when D0 is 1. So here output D0 is 1. So output both Q0, Q1 are 0, 0. So you see both are 0, 0. No LEDs are glowing. Then next is D1 should be 1 and rest should be 0. So D1 is 1 and rest should be 0 in the serial number 2. So at that time you see Q0 LED is 1, Q1 is 0. So that is why Q0 LED becomes red, whereas Q1 is not glowing. Now next input is D2. So you see except D2 other are logic 0 in serial number 3, and at that time Q1 is logic 1 and Q0 is 0, and D3 serial number 4 1 1 means both LEDs are glowing, and that means it is selected D3. So that is the truth table verification of 4 to 4 cross 2 line encoder. So this is the encoder circuit realization. So now in today's class we have learned what is decoder, what is encoder. Decoder is a combination logic circuit which converts your n input line to maximum 2 to power n output lines. And as an example, we have verified the truth table of 2 to 4 line decoder as well as encoder circuit. Then encoder is a combination circuit again that performs the reverse operation of decoder. It has a maximum of 2 to power n input lines and output lines. Hence, it encodes the information from 2 to power n input to and n bit codes. And its truth table also has been verified through virtual laboratory. So I hope you could understand. You just try this virtual laboratory available at the given link. So this is the home page, aim, implementation and verification of decoder. Demultiplexer is a special case of decoder where only one input is there and rest and there are multiple outputs, but that is enable line, and other inputs which we use in decoder works as a selection line in case of demultiplexer. So we will do later on this thing, and encoder using the logic gate of OR gate. Here we have used AND gate as well as NOT gate. So with this, thank you for attending this class.